Okay, so this is the session on encoding live and on-demand video using HEVC. We're going to spend a good bit of time talking about the market situation for HEVC, some alternative codecs, and towards the end we'll get more into the production side and the playback side. Wanted to start off with some simple questions. That's not it. That's not it. That's closer to the truth. And it's not just me. So this is a comment from Dave Ronca, Director of Encoding Technology at Netflix. And Netflix is part of the Alliance for Open Media. This is a comment he posted in the last couple of days to an article I wrote on the Alliance for Open Media. And he's talking about the Alliance for Open Media. There was a gentleman who posted and said, standards make the video world, and this is Dave Ronca's response to that. And he's a very respected technologist, as you would imagine, because he's the guy who picks technologies for Netflix. And his comment was, the Alliance for Open Media, we're testing the theory that we can do better with the royalty-free codec. And his last comment is if the Alliance for Open Media is a technical success, and the codec survives legal challenges, then the era of royalty-based codec will end, as it should. So, do I think HEVC is going away tomorrow? No, but I think it's, anybody looking to adopt the technology should understand the environment that we're looking at. And again, it's not only Dave Ronca, although this was an interesting point. His question, if it survives legal challenges, you kind of wonder what he knows that nobody else knows, because we haven't heard a lot about legal challenges for the Alliance for Open Media. But it's not just Ronca, there's a lot of other people. This is a gentleman from Quick Play Media who says HEVC might be the first case of a very promising codec going past its shelf life without any serious deployments to its name. Now, I think a lot of people would question that HEVC has already some serious deployments. I mean, Netflix is using it, Amazon is using it, it's a lot of smart TVs. But I think the point is, we're at an interesting point in the codec technology space where standards don't necessarily have to win. And again, if you're looking at adopting HEVC down the road, which is presumably why you're here, then I think this is stuff you need to think about. And I think to kind of summarize why HEVC is in the situation it's in, we would just look at this slide, and it would be that pigs get fat, but hogs get slaughtered. And I always wondered if it was hogs got fat and pigs got slaughtered, but this is the one I found. So I think, HEVC came out, the initial royalty set from MPEG-LA, when we'll cover all this in the presentation, the initial royalty set from MPEG-LA was pretty reasonable. HEVC came out with, HEVC Advance came out with very, very aggressive royalty demands that they scaled back on, but I think it created such an uproar in the community and such a financial incentive for companies like Microsoft, Google, Amazon, Intel to create an alternative codec that it really could be a force that overwhelms HEVC in a lot of different markets. So this is the agenda for today. Again, I want to cover the royalty situation for HEVC because if you want to use it, you may have to pay for it. I want to cover the competition. There's some interesting competition coming that we didn't know about last year. And again, if you're looking at specific market implementations of a UHD codec, you should know about that. There's been some reports about HEVC that kind of put the quality a bit in question as it relates to both H.264 and Vp9. And then the point I want to get to that I think is really interesting from my perspective is I want to examine the inherent value of a standard. And we're going to, 15 years ago when we looked at analog TV, or 25 years ago, we needed a standard. There was long-term shelf life. There was a lot of different vendors who needed interoperability. There was no software upgrades. And we're moving away from that. And I want to talk about that in the specific markets that HEVC is going to serve. Contribution, backhaul, distribution, OTT, DTV, and look and see where that standard has an inherent value that will sustain it over a lot of these other competitive technologies. Then we'll look at where HEVC encoding and playback is, and then we'll look at some issues about producing HEVC itself. So point one about HEVC is royalties or pricing. There's four potential checks you have to write with HEVC. And today we know the numbers for the first two, MPEG-LA and HEVC Advanced. I'll cover this in a second. Technicolor was originally in the HEVC Advanced patent pool, and then they backed out. So if you want to use HEVC, and we don't know if Technicolor is going to charge a content royalty at this point or just a playback royalty. We don't know what they're going to do because they haven't announced. So that number's unknown. And then there's always this concept of a third pool, and we're not sure if that's just a grassy knoll kind of threat, but there are definitely IP holders for HEVC that haven't announced contribution to either pool. So, here's the numbers for MPEG-LA. Basically, it's pretty reasonable from an encoder-decoder standpoint. It's 20 cents per encoder-decoder. There's a de minimis exception for shipments in excess of $100,000, 100,000 units. Until you ship 100,000 units, you don't know anything. But there is a $25 million cap. And that $25 million cap is up from, I think H.264 is around 8 million now. And of course, that's in addition to any royalties you would pay for H.264. So, but there is no HEVC content royalty, even for pay-per-view or subscription, and that's different from the MPEG-LA H.264 royalty pool, where there was a royalty for subscription and pay-per-view content. And here's where the big numbers come in. So this is the HEVC Advanced, and this is a patent pool that came into being, I think it was in April of 2015. And again, they announced these per unit royalties, but when they first came out, it was without a cap. And now they've backed off on that. And I think in December of last year, they announced these numbers, which were capped. Basically, it's between 80 cents and I guess between 40 cents and depending on the device, as high as $1.20 a unit. So MPEG-LA was 20 cents a unit. HEVC Advanced is $1.20 a unit, and the maximum royalty is 40. So if you're Amazon or I guess more to the point, if you're Apple and you're shipping mobile phones and you're shipping connected devices, then the most you can pay is $40 million. And that, of course, is on top of the $25 million that you have to pay to MPEG-LA, and it's on top of the royalties that you're paying to MPEG-LA for H.264. So, and then if you're, from a content perspective, if you're Netflix or Amazon or Apple on the content side, there is a pay-per-view subscription royalty, and there is a royalty on, there is a royalty on pay-per-view, there is a royalty on subscription. The maximum combined royalty on that is going to be $5 million. And then the other IP, as I mentioned, Technicolor was originally in the HEVC Advanced pool. They withdrew in February 2016. There's no terms what they want on their website. And again, the Broadcom, Qualcomm, VXS, and Magnum are all known HEVC patent holders who haven't announced that they're part of any pool. So if you're gonna be using HEVC, whether it's content or playback encoding, you're gonna have either a royalty known or the potential for a royalty, because we don't know what these unknown vendors are going to do. So if you look at what this is going to cost companies, I mean, you look at Apple, between their iDevices, between iTunes, between Apple TV, they're going to be paying $25 million to MPEG-LA, $45 million to HEVC Advanced. Google is kind of in the same boat, but they don't have the content. Microsoft, if they're $25 million and $40 million if they decided to put it in the operating system or Internet Explorer. Samsung, hardware vendor, does TVs and phones. They're in the $65 million club. Amazon is in the $70 million club because they're doing both devices and content. And Netflix, Major League Baseball, other could pay as much as 2.5 or 5 million depending on how they price their products. And I guess the point of these numbers are, we're going to look at the Alliance for Open Media. You can hire a lot of codec engineers for $65 million a year. So if you're Microsoft and you're Google and you're saying, okay, we can use HEVC, but it's going to cost us $65 million, and we've got to get involved in this huge standards process where we only have one small voice in the matter, or we can join our own alliance with other like-minded companies. it's going to cost us a whole lot less to throw 20 engineers at the project than it would to pay the $65 million to HEVC Advanced and MPEG-LA. And then on the content side, I think the numbers are small for Netflix and Amazon on the content side, but you get a seat at the table, which I don't think they currently have to that extent on the standards, the HEV standards process. So we're going to look at the Alliance for Open Media in a moment, but I think the motivation for a lot of the companies that joined that was, they're going to have to spend a lot of money and they're not going to get a big seat at the table. I think that's why there's a lot of momentum away from HEVC in those space. Now, I think, 2 years ago, Vp9 was kind of it was used by YouTube. I don't want to say it was a joke, but nobody else was using it. It was kind of YouTube's baby. And we're seeing Vp9 finally getting traction in the marketplace, and that's very new. That's as of NAB this year. We're seeing the Alliance for Open Media get hardware support from different vendors that joined it in the February timeframe. And then we're seeing a company called Vnova Perseus, or Vnova Perseus is the codec, and it shows that the joke was on us. And what was kind of funny about Perseus was they came out on April Fool's Day in 2015, and they made all these claims that were pretty aggressive. And so a lot of the codec people were saying, it's a joke, it's not real. But I think what they've accomplished over the last 12 months have proved that it is a real technology. And again, I think it's another alternative to HEVC that we didn't know about last year. So looking at Vp9, what's happened in the last 4 or 5 months? JW Player announced that they're going to use Vp9 in their OVP. So JW Player is a very major player technology, off-the-shelf player technology, plus they're a very growing player in the online video platform space. So that's Brightcove, Uyala, Kaltura, the traditional big three, but I think JW Player is definitely making a move there. We're seeing encoding support from Zencoder, which is one of the top 2 or 3 cloud encoders, and Brightcove is committed to including Vp9 in their OVP by the end of the year. Telestream is pretty big in the enterprise space. They've announced that they're going to support Vp9 in Vantage. We're seeing the first live encoder available. Wowza has firmed up support for Vp9 transcode, as well as transmuxing in their Wowza streaming engine. And we're seeing a lot of increasing hardware support on the system-on chips and graphics cards. So again, Vp9 in the last 12 months has really moved from YouTube's baby to a full-featured codec that a lot of people are going to be using. And the benefits of Vp9, why Vp9 compared to HEVC? Well, it's free, and that's always good. The quality is the same as HEVC, more or less. We're going to look at some numbers on that in a few seconds. Unlike HEVC, it's got ubiquitous playback in all current browsers that aren't Safari, and it's got playback on Android. And then YouTube has never really tried to use the muscle or Google's never tried to use the muscle of YouTube to direct codec usage, but they're going to be announcing that UHD is only going to play on YouTube in Vp9 format. So currently, you can view 4K videos on YouTube in either H.264 or Vp9 format. They're saying that they're going to stop the H.264 playback and just go to Vp9. Why would they do that? Because they should get a lot lower data rates with Vp9. So what does that mean when YouTube says we're only going to support Vp9 for UHD videos? For me, from my perspective, if I'm a product manager of a smart TV or a retail OTT device like a Roku or a Chromecast, I'm going to be supporting Vp9 because I'm not going to build a device that's not going to be able to support YouTube playback at 4K resolution. So I think it's, they're using the market force inherent to YouTube to kind of direct what the supporting playback technologies are going to be doing. Okay, so here's the Alliance for Open Media. It was launched in, who here has heard of the Alliance for Open Media? Who here hasn't? Okay, so the Alliance for Open Media was launched in September 2015. Streaming Media has covered it all along the way. If you Google Alliance for Open Media in my name, then you'll see an article I wrote for it back then. And it includes technology providers, Cisco, and Thor's in parentheses. Thor is an open source codec that Cisco had launched, I think last July. And I'm laughing because it's the shortest-lived video codec ever, right? I mean, it was launched in July, and it was kind of folded into the Alliance for Open Media in September, so it had a 2-month life. It's kind of a codec person joke. Maybe it's... Anyway, Google with Vp10, they folded that into the Alliance. Intel, Microsoft, Mozilla. Mozilla was developing an open source codec called Dala. And so the technology side has pretty much all of the major open source codec developers are now consolidated into one development team. And again, why would Google do that? Why would Intel do that? Why would Microsoft do that? Because it's a whole lot less expensive than spending $65 million with HEVC Advanced. On the content side, we have Amazon and Netflix, and that's in addition to YouTube. And then in April 2016, NVIDIA, ARM, and AMD announced that they were joining the group. So what's the significance of that? Obviously, if you've got those companies in play, it means pretty aggressive hardware support in system-on-a chips, graphics cards, CPU, CPU-accelerated playback. Now, the overall schema is, again, they're consolidating the open source development for, that was for Vp10, Dala, and Thor into one open source codec. All output is going to be royalty-free. And the first codec, named the AO Media 1 codec, or short as AV1, is scheduled for release between December 2017 and December 2016, that should say, and then, I got this mixed up, and March of next year. So it could be as soon as the end of this year, should be no later than March of next year. Why are we pretty sure they're going to make that deadline? Because the first iteration is going to be largely based on Vp10, right? So Vp10 is the codec that Google has been developing for a while, and they're pretty confident that they'll be able to get that plus some advancements from Dala and Thor out by that time frame.
Based on 9?
Yes. Based on 9, better, higher frame rates, higher color depth, better support for UHD is kind of the concept. So what does all this mean? What's the impact of the Alliance? Well, in terms of browser support, well, because of the Alliance, Microsoft started including Vp9 in Edge. Now, that doesn't do anything for people who have Internet Explorer, and that kind of stinks. But in 2 or 3 years, Edge is going to be the dominant Microsoft browser, and Internet Explorer should be gone. I'm sorry, that's a mistake. It's not in Safari. Vp9 is now in Chrome, Firefox, and Edge, not in Safari. And then I think, because Google, Mozilla, and Microsoft are members of the Alliance, we can be pretty sure that that those companies are going to integrate AV1 quickly into their browsers. So, Vp9 is in there now. AV1 will be in there as soon as it's available. On the content side, I think, Netflix has made their point clear, right? This was the first quote I showed from Dave Ronca. They intend to support the technology. And then Amazon, they're a founding member as well, and YouTube will certainly use it. So again, you've got 3 major vendors on the content side, 2 on the pay side, 1 on the free side, and that's really going to push hardware support for that technology. Again, if you're a product manager for a smart TV today, you're looking at what hardware decode do I need to support going forward. The AV1 codec almost has to be on your need list. You've almost got to start putting that into something that putting that into your spec that has to be implemented. And then it's going to be easier than it has been with codecs like Vp9 or Vp8, because you've got members of the Alliance who do hardware decode on the graphics side, system on chip side, and CPU side. And then, so you've got browser support immediately, you've got content support that's going to drive hardware support, and then you've got the ability to implement hardware support very easily. And then this is kind of to Ronca's point that the whole if it survives legal claims, you've got a bunch of companies with huge war chests to fight any IP claim against the codec. So I think if it was, Google's got enough money to fight any defense fund in itself. But if you combine Google, Intel, Microsoft, then really they should be able to push this through against almost any patent claims. So it's a big deal. And then new to the mix, this is the company Vnova Perseus, where the company is Vnova, the codec is Perseus, and they're going after, at least initially, a pretty discrete, but I think very, very important value proposition, and that is they can deliver HEVC or Vp9-like performance without hardware upgrades to either encode or decode. Let me say that again. They can deliver HEVC-like performance without hardware upgrades to either the encode or the decode side. So their first deal is a deal with Sky Italia, or Sky in Italy. And what they've done there is Sky is software upgrading existing STBs that play back H.264. They're upgrading those with software to play back this Perseus codec. They're upgrading their encoders with software plugins, and I think it's Thomson encoders. It could be harmonic. So basically, there's no infrastructure cost. There's no CapEx. It's all software. But they're cutting the data rate of the video that they're distributing to these devices by 50%. So why has HEVC upgrade been so slow in existing markets? Because it costs a lot to replace set-top boxes. Well, the value proposition for Perseus is you don't have to replace your STBs. You can just piggyback on their H.264 decode capabilities and play our codec. And again, the numbers from Sky are 50% reduction in data rate over H.264 at the same quality. And I was actually in Milan and saw demonstrations of this. And you're always, you never know what you see on a TV, right? I mean, there's one TV here, one TV here. One was Perseus, one was H.264. And at very, very low data rates, there was, so 8 megabits per second here for H.264, 2.5 megabits per second here for Perseus, and I saw very little difference, or really no difference that was meaningful. In an article that you're gonna see in Streaming Media Magazine in June, I ran some PSNR numbers and some other statistical numbers, and those were a little bit less favorable for Perseus. The numbers weren't, I didn't see 50% better than H.264, but the numbers, it was better than H.264 in a lot of different configurations. So I think, sometimes objective benchmarks don't reflect reality, and this could be one of those examples. What I saw in Milan seemed to reflect this reality. But the HEVC is not playing here, right? So the cool thing about this is HEVC isn't saying, hey, we can upgrade your STBs without hardware upgrades. They can't do that. But this is an example where a niche can, and it's not, if you can upgrade your entire infrastructure without paying the CapEx and get 50% better bandwidth, then that's a huge deal in a lot of different applications. And then the other point about Perseus is it's used for contribution by Sky for at least 2 or 3 years. So it's not just a distribution codec, it's also a contribution codec. And what's interesting about this is these are two traditional markets where we thought standards were critical. We thought standards were critical in distribution because you've got to have compatibility between your encoder and your set-top boxes. Sky Italia doesn't care. If they can get software upgrades with a proprietary technology and reduce their bandwidth cost by 50% and increase their available subscribers, that's a big deal. They don't care about standards. And same thing on the contribution side. Contribution is point-to-point closed system. Standards don't really matter. And then, where's browser going to be in the general market? Most of us produce for, general streaming to the browsers. That's where it's unclear to me. They've got to come up with a strategy to kind of implement that. But from my perspective, the value proposition that they're seeking is a huge market if they can successfully, prove it in the U.S. and in other markets besides Italy. Okay, so want to just mention a couple of things about the quality of HEVC. I've pretty consistently found the quality of HEVC to be as claimed. It can deliver the same quality as H.264 at a lot of very relevant resolutions at about 50% of the data rate. Moscow University is a very highly respected codec. I guess they spit out a lot of codec engineers, and they put out a test every year that measures the performance of H.264 codecs. And for the first time last year, they included HEVC and Vp9. And we're going to look at those results, and those were not as positive for HEVC as what I found. So my test, again, the expectation was same quality as H.264 at 50% the data rate. I tested 3 files: the Sintel file, which is an animation from Blender, the Tears of Steel movie trailer, and then a real-world video that I created from 4K clips that I produced myself. And then I had 2 HEVC configurations, 720p at 2 megabits per second, and then 1080p at 4 megabits per second. And then I compared that to the quality of H.264 at essentially twice the data rate, and 150% of the data rate to see where the quality would lie. And then I assessed the quality using the Moscow University video quality measurement tool. So this is what I found here was that, so these are the different test clips. This is the VQM values. Lower scores are better. And then basically if it's green, it meant that at half the data rate, HEVC was better or same quality as H.264. So basically what I'm saying is in 4 of the 6 test cases, HEVC was as good as H.264 at 50% the data rate. And then here, what I'm saying, in all cases, when you extended the data rate for HEVC a little bit more, you got to parity. So I think what we're seeing is that H.264, the quality is not the big limitation. I think it really, these are pretty early numbers. HEVC will advance over the next few years. At this, we've got 4 of 6 test cases where it was the same quality at 50% the data rate. If you extend that up to 66% of the data rate, you meet all of the test cases. So quality is not going to be the issue with HEVC, at least in my tests. And HEVC was tested by Moscow University a lot more extensively. They looked at 8 HEVC codecs, including X.265 and 2 codecs each from Intel and Idiom. They compared to Google's Vp9 and X.264. And X.264 is a very good codec, and they've used it a lot more extensively than I have, so they could have better numbers. They use PSNR and SSIM to evaluate and compare their technologies. And the best HEVC codec they found was X.265. And one very, very interesting point and key point of this chart is that there's a huge difference in quality between different HEVC codecs. So we like to think of HEVC as this broad standard, homogeneous, but it's not. And I've done I just recently completed an analysis for a consulting client where I saw X.265 was probably 40% better than the HEVC codec that was in their encoder. So if you're going to look at encoding HEVC, make sure you have access to the best codec, which clearly, in my view, is X.265. So what's interesting here is that X.265 is here, Vp9 is here. Now, last year was a really big. We saw a lot of different comparisons that came out. Some comparisons said Vp9 was no better than H.264. Some comparisons, like mine, said both Vp9 and HEVC deliver the same quality as H.264 at half the data rate. And I think it's a huge deal that that Moscow University kind of confirmed what my findings were. What's also interesting, though, is that X.264 was only about 20% worse than HEVC. So from my perspective, this was a huge deal because these guys, I mean, they know what they're doing. I mean, I think I know what I'm doing too, but when a very respected source comes up with different numbers, you have to look at it and say, wow, that's interesting. So again, you know, last year before these results came out, I think everybody believed that HEVC was delivering on the quality promise. These kind of make you think that X.264 might have a little bit more life than everybody thinks. And then how does HEVC compare to Vp9? VQM, lower numbers are better. SQM, higher numbers are better. Green is higher quality. So, you know, in these 9 comparisons, Vp9 won 2, X.265 won 7. Here it was 6 and 3. You know, the difference here was 9% between the two. The difference here is it was less than 1%. So from my perspective, you know, at 1, HEVC has proved the qualitative benefit over H.264, although you really have to look at those Moscow University results. Number 2, the quality difference between Vp9 and HEVC is commercially irrelevant. No, you can.
The question was, for the Vp9 tests, did you have issues with rate control?
Say it again?
Did you have issues with rate control?
Okay, so did I have issues with rate control? Meaning, you know, within the clip or?
So, like, if you're doing a test targeting a specific bit rate or whatever, find that Vp9 undershot or overshot significantly, because I found that to be a huge problem with libVPX anyway, that kind of thing.
So did I have a problem with rate control? Nothing that that jumps out. I mean, typically when you produce files like this for a test, you obviously have to compare file sizes.
Right.
But I don't remember having a huge problem. I might have, you know, I get within 5% for my test, and I don't remember having a huge problem doing that. But the problem with Vp9 and HEVC is it takes so freaking long to encode. So if you miss by 6%, it's like, oh my goodness, you know, you could spend a couple of hours re-encoding. Okay, so you know what's the impact of the MSU report, Moscow State University report? Again, raises some questions about X.264 quality. Anybody compare HEVC and have any other statistics to share? Anybody done that work? What did you find?
I mean, I found it's hugely better for 4K, massively better, especially when you're doing VR encoding, where you have stacked top and bottom, you have 4K by 4K.
HEVC or?
Comparing HEVC versus ABC.
Okay.
ABC
What about Vp9?
Vp9 also very good. Not quite as good as HEVC, but very similar. Minus the rate control problem.
Okay. Okay, so we're going to look at the concept I kind of threw out there at the start, the whole quality of the standard issue. And these are my assumptions going forward, and this is going to affect, I think, what happens in the marketplace. But you know, let's assume that YouTube only serves UHD content with Vp9 and AV1, and that's what they've stated to me. So I assume that to be true. Let's assume that Netflix, Amazon, and YouTube all support AV1 when it comes out, and you would assume they would do that because they're members of the alliance. As do Microsoft, Google, and Mozilla in their browsers. And let's assume that Intel, AMD, ARM ensure GPU hardware acceleration for AV1. So I think based on those assumptions, you can think that by 2018, most major chips, systems on a chips, graphics chips, and mobile devices will accelerate at AV1. And I think that every smart TV, retail OTT, or commercial STB will support AV1 as well. And then I'm not saying they won't support HEVC. I'm not saying that's going out the window. I'm saying you would have to be a blooming idiot not to look very hard at supporting AV1 in a product you're going to ship in 2018, even if it's just YouTube. But if it's YouTube, Amazon, and Netflix, then you'd have to be, and really, the cost of supporting an additional codec, if you're not paying a royalty, is minimal. So, why wouldn't you support it? And then we know that Android devices will accelerate at AV1, and we'll talk a little bit more about Apple in a second. So if all this comes true, in what markets does the standard retain significant value? And then I think, again, the concept is, what's the inherent value of a standard? And when, 2 years ago or 3 years ago, HEVC came out, I thought This is a standard. It's going to replace H.264. Vp9's a joke. Forget all these proprietary technologies. They don't matter. Because my experience in the video codec world has proven that to be true. But if you look at where we are now, and if you look at some of the history in a different light, you'll see what I'm getting at. So clearly, in traditional analog broadcast, you've got a playback environment that's hardware only, non-upgradable, and a long-term usage cycle. When we bought our black and white TVs, we wanted them for 10 years, right? So we wanted something that worked. You had a disparate group of vendors on the encode decode side, and the value of the standard was critical to this succeeding. So the standard had to work. There had to be a standard that everybody followed, or it all fell apart. So this is where a standard really had a lot of value. Now let's look at different markets that HEVC is playing in and other technologies are playing in. So backhaul is basically getting the video from the stadium to the main encoding station. And again, this is a closed system. What do you care about if you're buying for backhaul? You care about latency, bandwidth, and quality. What's the inherent value of a standard? There is some. Interoperability is always good. But most of the time, you're probably buying encode, decode from the same vendor. So you don't really care if it's AVC, Vp9, HEVC, Perseus. You just want to make sure that it's fast, it's low bandwidth, and it looks great. Okay? And again, these are my thoughts. This is just my analysis of different markets we assume HEVC will succeed in. And contribution is kind of the same. So contribution is distributing high bit rate video to different places where it can be transcoded and then distributed. And again, it's a closed system playback environment. You care about latency, bandwidth, and quality. Again, interoperability is an issue. You'd want everything to play together nicely, but you're probably going to buy encode, decode from the same vendor. Again, just point out, Sky in Italy is using Perseus. All they cared about was the fact that it lowered their bandwidth costs from point to point on their distribution channel. So they don't care about standards. They just wanted fast, low latency, high quality, low bandwidth. And then we look at desktop and notebooks in the browser. What do I care about if I'm distributing to these platforms? Well, I care about the fact that it plays, right? So this environment, it's open system, but it's software upgradable, right? So I can send a new codec in a browser. I can send a new codec in a plugin. Standards have much less value. It's interesting. If H.264 was incredibly successful in the computer space, why was it successful? It was successful because in, what year was it? 2006 maybe? Adobe put it in Flash. So did it succeed because it was a standard, or did it succeed because Adobe put it in Flash? My perspective, looking at one time, I thought it succeeded because it was a standard. Looking back, the codec that was in Flash before H.264 was what? Anybody? It was Vp6, which was a proprietary technology from Onto. So the most successful codec before H.264 in computer playback was Vp6. Why? Because it was in Flash. Why? Because all we care about is availability of playback. And today, HEVC gives us none in the browser. So if so why did JW Player decide to use Vp9 in their OVP? Because it cuts their customers' bandwidth costs, and because it plays in Chrome, Opera, and Firefox, and in Edge. So do they care about a standard? From my perspective, they don't. They just want it to play. And then the key question is, why would you pay, if you're Google or Microsoft, and Mozilla will never pay it, but why would you pay $65 million or $40 million to anybody to get playback in your browser if you can get Vp9 for free? And I don't see here where the standard brings any value to this market. So will HEVC win in this market? Certainly not that I can see. So let's look at some additional markets. So IPTV, my definition of IPTV is the vendor supplies the STB, right? So it's essentially a closed system. When I go with Comcast, when I go with With DirecTV, I get my decoder from the service. I don't care what it is. So it's a closed system. They decide which codec to use in that. So what's the value of the, what's my primary concern? Cost, quality, and bandwidth. What's the value of a standard? I think it's pretty minimal. So, again, Sky in Italy upgrading their existing STBs with vNova Perseus because it cuts their bandwidth cost by 50%. Do they care about the standard? I think everybody would like everything to work with everything, but at the end of the day, it's a closed system. Compatibility is not an issue. What does HEVC bring to this market that Vp9 or Perseus can't do? In a closed system environment, I don't see it. And then we look at retail OTT, and this gets closer to the concept of analog TV. This is an open system, right? There's nobody's putting a Roku box or an Apple TV in my house. I'm buying one and I expect that it will play with all the content that's available out there. So I think compatibility is a big deal in the retail OTT market, and the value of the standard is significant. But I think this works both ways, right? I think these companies need HEVC for short-term legacy, but looking at the fact that Netflix, Amazon, and YouTube are going to be supporting Vp9 and AV1, I think in the longer term, these devices will say, I need to support AV1 and Vp9 playback. And Roku 4 already supports Vp9. So we're starting to see some support for proprietary codecs in these particular markets. Why wouldn't you support AV1 or Vp9? It's necessary for 4K YouTube playback. It's necessary for Netflix and Amazon if they cut over. So, I think we're going to see a lot of support for Vp9 and AV1 in this particular space. And then mobile, I think, is, we'll cover this here. We'll cover it a little bit as well. I think mobile is the big issue where HEVC has made pretty significant inroads. And what's the primary concern in this market? It's battery consumption. The UHD codec that has hardware co-processing in this market is going to win. The value of the standard is significant because you need inexpensive hardware. And Apple already has HEVC on the iPhone 5. They're only using it for FaceTime. They're not using it for general playback. Android has HEVC in Android 5 and software, and there's hooks to include HEVC hardware playback as well. It's important to understand that Google doesn't pay the royalty on this to either HEVC Advanced or MPEG-LA. Their licensees pay the royalty. So you can't say, well, Google's going to pay $45 million and they're going to pay the $65 million for this, so they might as well put it in Chrome, because they don't think they're going to pay $65 million. And then they're not going to reach the maximum with these products. And then I think there's a general concept that Apple is really behind HEVC, and they'll never adopt a proprietary technology like Vp9 and AV1. And I don't know if you can call AV1 a proprietary technology. I don't know what you call it. I guess it's not a standard, but it's not proprietary either. But I think Apple is going to pay a whole lot more in royalties. Apple's not part of the HEVC Advanced pool. So they're going to pay $45 million a year to HEVC Advanced. They're not going to see a piece of that. So they're part of the MPEG-LA pool, and they've got one patent in the entire pool. So a lot of people think, well, Apple is not supporting any proprietary codec because they're in the MP4 H.264 patent pool in HEVC. My response is, they're going to end up spending a lot more for HEVC than they're going to get. Why wouldn't they look at these other technologies, just like Microsoft is a member of the alliance, just like Google? And if Microsoft doesn't come. What they told me when I was talking to the people from the alliance is they're talking to Apple, and Apple's interested. But Apple talks to everybody. Nobody's making any claims. But I think if you assume that Apple will never support Vp9 or the AV1 codec because it's part of the HEVC patent pool, I just think that's a misconception. I don't think that will ultimately keep them away. Yeah, and I just wanted to be clear that it's not, it's not Microsoft or anybody from the alliance saying that. I think Apple's going to make the best economic decision for them, and I think the best economic decision for them is to. I don't see consumers don't care what's in the phone, right? So they just want low band, they want low cellular costs. So if it's HEVC, if it's Vp9, if it's AV1, they don't care. So what's the inherent value of the standard that would make Apple want to pay $65 million a year? And I just don't see it. So I think they were, back when it was 25 million, maybe that was reasonable. They were getting a piece of it. And then really this goes back to the slide, pigs get fat, hogs get slaughtered. I think everybody was on board with HEVC when it was $25 million a year cap. I mean, that was manageable. It's a lot of money, but I think HEVC Advanced came out and they had no cap. I mean, Apple was looking at hundreds of millions of dollars, and they backed off that claim. But I think there was like a 6-month gap where a lot of people had to really scramble to figure out what they were doing for UHD video. And I think that's when all this was hatched, clearly, and I think they're going to go through with it. It makes a lot of economic sense for everybody who's part of the group. And I think it makes a lot of economic sense for Apple. I mean, I calculated as of September of last year that if Apple paid the full royalty, it would be $120 million for the first year to HEVC Advanced. And that pays for a lot of codec engineers. I don't know why they wouldn't be part of it. Closed systems, again, closed system is a great market for early adopter, codecs, because it's closed system. You don't really care what it is. You just want it to work. You want it to be cheap. You want it to be efficient. Not a lot of inherent value to the standard. I think HEVC has a great lead here because it's been in place for since 2013. But if you can get a technology that works just as well for the same price or cheap or for a lot less money, then I think you look at it very closely. So the value proposition for an HEVC licensee, whether it's Samsung or a smart TV vendor, is you can pay up to $65 million a year for HEVC, or you can let Google, Microsoft, basically the Alliance for Open Media, do the work for you. And you pay nothing. You can use their technology, pay nothing, and get the same performance quality as you get with HEVC. And I think many are going to have to do it for, they have to do both for a while. I mean, Samsung's not going to drop HEVC. They'd be silly to drop HEVC in the short term, but I think in the long term, the AV1 codec is going to open up a lot of opportunities for dropping HEVC. So again, this goes back to to my point on the inherent value of the standard. The fact that most devices are software upgradable, the fact that there are viable, well-supported alternatives. I mean, the AV1 codec is not Og Theora. It's not an open source project. It's a well-funded project from serious companies who want to use it for a lot of mission-critical business cases. So it's not it's not Og Theora. Hardware is much less expensive to create. So it's very, very easy to include hardware support in systems on chips, CPUs. You've got shorter product life cycles. So if Apple, it's not a 10-year TV anymore. It's a 2 or 3 year smartphone. If Apple decided to drop HEVC in the iPhone 7 to the iPhone 8, they can do that in 1 or 2 years. And then you've got a lot of closed systems where the standards don't really deliver a lot of value. So the bottom line is Vp9 offers a lot of access. I can access all those people in browsers, all those people on Android. HEVC can't match that today and probably never will. I don't see free HEVC playback in the browser ever. Any questions on that? I mean, that's kind of the meat of the. I really wanted to present this as more of a flow of ideas. Any reactions to that?
I see a lot of change happening, and nothing is quite, I guess, nailed down. A lot of influx, things afoot. Quite have anything nailed down.
I think it's gonna vary by market, but and you raise a really interesting point because at the start of 2015 it looked like a very logical succession from H.264 to HEVC, and that was all blown up. So I think HEVC is really not going to succeed in a lot of very significant markets. The browser. I mean, Avni is going to be talking on this, and she's got a lot of more market research than I do. I know the quality side very well, but so there's more coming at this conference on these issues. But I see, looking at the different markets, I see the market Perseus is playing in. Upgrading STBs, HEVC it's a huge market. HEVC will never play there. Browsers, HEVC will never play. Mobile, I don't really see how that's going to play out. But I could really see Apple dropping HEVC and Android doing the same.
What some of the, I guess, closest companies like that market?
Say it again?
Like, how Comcast has like mobile viewing. How do they handle that closed system? Well, it's not closed, it's actually in that arena.
I mean, I guess my concept of open and closed is if they tell you what device you have to have, it's a closed system.
Right, but then doesn't it force like companies like that are already in closed systems when they start introducing more streaming platforms to become, I guess, more open system adopts more standardized production?
I'm sorry, I'm just not following your point.
On like a closed system, for example,
Yes.
their set-top box.
Right,
They're starting services now. You can stream a lot of that content as well.
right.
So make it less of a closed system. How are they handling? I guess are they adopting more of the standards?
I don't know what they're doing. And again, that's where Avni is from Frost & Sullivan, and she talks to a lot of the vendors, and she knows. When is your session, Avni? Okay. So if you're interested in this stuff, and she's much better for what vendors are doing, kind of. But the pardon?
I'm not sure if it's
So again, I think mobile is kind of I don't know what mobile's going to do. I think computers don't need, the battery life isn't an issue. They will be AV1 or Vp9. Mobile, I think it's going to transition to AV1. I think smart TVs, commercial STBs, the ones that you install with Comcast, those will stay HEVC for a lot longer. But I think there's going to be big markets that ignore HEVC in the long run. But so let's move on to encoding HEVC, and let's look at where HEVC plays and some techniques on how to encode. So I think pretty much by this point everybody encodes HEVC. I don't think encoding is going to be an issue. We're starting to see the first wave of smaller live encoders. That's always good. And then Intel has the VCA that a lot of software vendors are using to accelerate HEVC encode. Where will HEVC play? Covered a lot of this before. Basically, this says HEVC playback. And these are older computers. What I tried to do with these tests is, what streams can you play on? I think this is a computer from 2005, and it plays a 720 stream very effectively, but it won't play 1080p. A 2009 Mac will play 720p. HEVC, it won't play 1080p, but this is a 2000, probably 13 or 12 notebook. It plays 720p and 1080p fine. So it really depends on which platforms you're targeting from a computer perspective, but I think 720p HEVC should play everywhere. Why is 720p relevant? I guess it's relevant if you're looking at HEVC as a cost reduction. If you want to reduce the data rate of your 720p video to get greater reach or to reduce your expenses, I think it's pretty safe on a huge swath of computers. And then what about the software side? I mean, the software side is where it's very weak. It's where it all falls apart because DivX 10 is out there. Installed base is over 10 million at this point. VLC Player has HEVC since November 2013. but you really can't count on that being out there. You know, you either want it in the browser or you supply it yourself in an app, and nobody wants to install apps anymore. So that's why browser-based playback is so important. Flash said they're going to include HEVC playback in prime time, but not in the general purpose Flash player. So that's not going to be any help. So basically, there's no general purpose HEVC players. It's got to come from the browser or the operating system. I don't see it in either in the short term. And then, and actually this is Microsoft, when they initially announced Edge, they said they were going to support HEVC, and now they support HEVC, but only if it's available in the hardware. Okay, so you don't, if you have software-only Edge, you don't get HEVC playback. If you have hardware acceleration on the computer, you do get HEVC playback here. What's the likelihood Firefox, an $80 million company, will ever license HEVC? 0. Apple, you know, we don't know what Apple's going to do. Microsoft has said they're dedicated to the AV1 codec, as had Google. You know, Vp9 support, it's unfortunate. We'll never see it in IE11. Microsoft only looks ahead. They're not, you know, they're not helping people out who have older browsers. But it will be in a shipping version of Edge sometime soon. It's only in the experimental version today. So 9 is pretty much in every current shipping version except for Safari. And I've not heard anything that tells me Apple is going to include Vp9 playback in Apple Safari or iOS at this point. So I think for computers and notebooks, CPU playback isn't the issue. It's just the player side isn't there.
Do you think the catalyst for the cost issue came about only because of HEVC advance, or without HEVC advance, would have progress still there to stay?
You know, my opinion is probably doesn't have a lot more value than anybody else's, but I really think it was HEVC Advance. I really, you know, because it, and if you spoke to publishers, I mean, there was a famous quote from Joe Inzerillo, who's the guy at Major League Baseball Advanced Media, and he basically said, you know, they're talking about a percentage of, when they came out, they said, we want a percentage of revenue. And that was, I mean, they basically said it was a showstopper, and for, you know, for a 6-month period, no publisher looked at HEVC, and everybody on the hardware side was looking at technology alternatives. And I think that's the period when, you know, it's ridiculous to have 3 open source projects. Like, why should Google and Cisco and Mozilla all try and create, you know, competition for, you know, for one open source success? So I think that it was during that time where that group was hatched. And I think in mobile, the issue is not, you know, the issue is battery life. So I think there's no retrograde or no retrofit market for mobile, because it really is all about the battery life. And what we're seeing is, you know, from an HEVC perspective, using HEVC cut the battery life from 8.6 hours with H.264 to 4 hours with HEVC. So, I mean, I don't know. How critical is that? How many of y'all have 18-year-old daughters? I mean, it's pretty critical to. So, you know, battery life is pretty important. So I don't see a lot of retrofit. I think it's all about, you know, what happens on the hardware co-processing side. What about Apple and iOS? Apple added HEVC encode decode to FaceTime, but only in the iPhone 6, meaning not on any of the iPad platforms. But I could be mistaken about that. But I'm not mistaken about the fact that it's not available for general purpose playback on the iPhone. So you can't play back HEVC on the iPhone, but if you use FaceTime, it is HEVC video that's driving that. And then again, Android went all in with HEVC, but this was before the Alliance for Open Media. So there is software decode on Android 5. Android 5, I think, is around 20 to 30% of the market at this point. And then there's also hooks to hardware decode as well. And there's some Android vendors who've announced support for hardware acceleration using those hooks. And again, this was announced before HEVC Advanced. Google's not going to say, we're going to direct our Android people to do different things than what we're doing on YouTube. But I think within Google as a whole, there's a lot of momentum towards the AV1 codec and away from HEVC. I don't know if that's going to change anything that you're seeing here, but I think that's the general trend. And then the mobile summary is, this is the market where HEVC looks the best, but a lot of the decisions were made before HEVC Advanced. And overall, I don't see any technology advantage over Vp9 or the AV1 codec. Where is HEVC on OTT and smart TVs? It's in the new Roku 4. It's in the Amazon Fire TV. Pretty much every smart TV shipping and most of the standards in this space are moving towards HEVC. So the hybrid TV standard is all HEVC, no Vp9 or AV1. The Smart TV Alliance is the same thing. And I don't know if those will change in the short term. I think HEVC has a really good beachhead in the smart TV markets, and that's not going to change in the next couple of years. Okay, so we're out of time. I don't want to keep you guys here. I kind of went over on the front side because that's where I saw the value. My website is streaminglearningcenter.com. I've got a few slides on producing HEVC, not a lot, but this presentation will be on my website later today, and then you can get the benefit of this. I felt the value was at the front, not at the back, so that's where I spent my time. Gotta go. Thank you.